I'll be going over solutions to every hard SAT geometry problem. This video will be part 1, specifically going over all of the problems related to area and volume. So diving right in, and all of these problems are 3 out of 3 difficulty. They're all from the SAT online question bank. For every question, I've included the question ID along with timestamps of when they occur in the video and a short description of each problem in the description below. So if you're doing these on your own and searching for a specific problem, that's where you can look. This will be the first of 4 videos specifically about all of the hard problems, or the ones that are listed as 3 difficulty. This is for all of the problems that are under the skill area and volume. Square A has side lengths that are 166 times the side length of square B. The area of square A is k times the area of square B. What is the value of k? All right, so this is just scale factor, specifically how it relates to area. So say we had one square was x by x, the other one has sides that are 166 times longer. So you could say that's 166x by 166x. You could treat x as 1, that would actually make the problem even easier. So this would just be 1 by 1, and then this one would be 166 by 166. And then just compare the areas. Well, if you know the rule with scale factors, for the side lengths or for the perimeter, it would just be scaled up by a factor of k. So k would be 166. But because this is dealing with area, you're scaling up the length and the width. So you have to multiply by k in both dimensions. So it's going to be multiplying the area by k squared. They don't do volume scale factor so much in the SAT, but if you did have a volume question where you scaled it up by a certain degree or a certain factor, then you would have to multiply by that scale factor cubed, right, for the length, the width, and the height. But in this case, it's just going to be 166 squared. And you can just type that into your calculator, which I'm going to go grab. So I've got it here. And I'll just type in 166 squared, which gives me 27,556. And I know that sounds like a huge number, but just think about it's getting 166 times longer and wider. Even if it went like 100 times longer, 100 times wider, then that would be 100 times 100, just 10,000 times longer. So it's got to be bigger than that. A right square prism has a height of 14 units. So when they say right, all it just means is that like the height compared to the base, like a capital B, like this area down here, forms a right angle. So it's just like a normal prism when you think of for a prism. In this case, square prism doesn't necessarily mean it's a cube, right? The height could be different than the side lengths, which we'll see it probably is. So the height is 14. It's a square prism, which means the base is a square. So they're going to be the same side lengths for the length and the width. The volume of the prism is 2,016 cubic units. What is the length in units of an edge of the base? All right, well, to find the volume, it's just going to be multiplying the 3 dimensions. So the length, the width, and the height. In this case, that's going to be x times 14. And they gave us that the volume was 2016. So 2016 equals x squared times 14. Or we could do 14x squared. If we want to solve for x squared, we would divide both sides by 14. The 14s cancel out over here, and then we'd get 2016 divided by 14, which gives me 144 is equal to x squared. And then you just think what number squared gives you 144, or you could do the square root of both sides. You don't have to worry about negative solutions because you can't have a negative length. And that would give me that x is equal to 12, the square root of 144. Units, it doesn't say what the units are. You don't have to bubble in units in the SAT, so it's just going to be 12. And to check that, you would just multiply 12 times 14 to make sure it actually gives you 2016. And it does. Right, so that checks out. A cube has an edge length of 68 inches. So a cube means that all 3 dimensions are the same, the length, width, and the height. So it's 68, 68, 68, like that. A solid sphere with a radius of 34 inches is inside the cube. Okay, so that means it's going to fit snugly in there because the radius is only halfway through it, right, from the surface to the center. Then to go the rest of the way down, it'd be 34 and 34, so it's 68. All right, but we got 34 there, such that the sphere touches the center of each face of the cube. So it touches the center there, all six faces. To the nearest cubic inch, what is the volume of the space in the cube not taken up by the sphere? All right, so we just do the volume of the cube minus the volume of the sphere, and that would be the space that's left over. So the volume of the cube will just be 68 cubed, I just multiply the 3 dimensions. The volume of a sphere is 4/3 times pi times the radius cubed. In this case, our radius is 34. So we would do it like that. And this would give us 68 cubed, 314,432. And then you're subtracting 4/3 times pi times 34 cubed from that. And when you subtract those, it gives us 149,795.7898. They round to the nearest whole number, so the 7. Round this 5 up to a 6, and then we get that the answer is A. The figure shown is a right circular cylinder with a radius of r and a height of h. A second right circular cylinder, not shown, has a volume that is 392 times as large as the volume of the cylinder shown. Which of the following could represent the radius, big R, in terms of r, and the height, big H, in terms of little h, of the second cylinder? All right, well first the volume of a cylinder is going to be the area of the base, which in this case the base is a circle if it's a cylinder, that's pi r squared, times the height. All right, so the volume of this cylinder is pi r squared times h, because we have r for the radius, h for the height. Now, if the volume is going to be multiplied by 392, then that would mean when you plug in these different values for the radius and the height, it should give you basically the same thing, pi r squared h, but with a 392 up front. So I'm just going to plug them all in, or plug them in until one of them works. So this first one, the volume would be equal to pi times our new radius is 8r. So that whole 8r is going to be squared, not just the r part. And then our height is 7h, so times 7h. So this one's going to get 8 times 7 bigger, because you're multiplying it by 8 twice and you're multiplying it by 7 once. So that would give us 448. And then you'd still have all the other things, pi r squared h. We want it to be 392, so it's not going to be that. Right? That's too big. All right, this next one, the volume would be equal to pi times, again, we have 8r squared. Oh, this one is going to be even bigger. So the last one was too big. This is going to be 7 times bigger than that. So that's going to be 3,136 pi r squared h. That's, again, not what we're looking for, 392 times the volume. All right, next we've got this one. The volume is equal to pi times 7r squared times 8h. So this one's going to be 49 times 8 times bigger, because you're multiplying the radius twice, so times 7, and then the height once, so times 8. This does give us 392 pi r squared h, and we know that pi r squared h is the volume, so you could say this is equal to 3 times the volume initial, or 3. This one's equal to 392 times the initial volume. Okay. So C is correct, and just to make sure that D is not also correct, they wouldn't do that on the SAT, but I think it's always worth doing, because if you end up getting another one that's right, then you'll know you messed one of them up. All right, so pi times, this is 49r squared, so this is going to be so D is also incorrect. So C would be our answer there. If you increase the radius by a factor of 7, that makes it 49 times the volume. And then if you subsequently increase the height to be 8 times the original height, that makes it 8 times bigger than that. So 7 times 7 times 8 gives you 392. Right rectangular prism X is similar to right rectangular prism Y. So that means it's like the same ratio of sides, you're just scaling it up. So right rectangular prism X, let's do it like that. That means that you've got a rectangle, and then you're extending it up to basically the same rectangle above it. Okay, the surface area of right rectangular prism X is 58 square centimeters. And the surface area of right rectangular prism Y is 1,450 square centimeters. All right, so we could see X over Y, or let's do Y in a different color. Maybe make a diagram. It should be way bigger than that, but This one's a little bit slanted, even though it's supposed to be right. If they gave us the surface area, it doesn't matter if it's surface area or area of a 2D shape, that's anything that's area and is measured in dimensions squared, it's going to be scaled up by the scale factor squared. Because basically for each side that you're calculating the surface area from, so the base and the height would be scaled up by that scale factor. And that would mean that x squared over y squared would be equal to 58 over 1450, where x and y are like a side length of that shape. The volume of the right rectangular prism, y, is 1250. So y cubed be 1250, like that. And what is the sum of the volumes? What is the sum of the volumes in centimeters cubed of right rectangular prisms x and y? Interesting. So they're asking for the sum of both of them. Well, first I'm just going to figure out, so the ratio of these is equal to k squared, which would be, let's see, 58 over 1450, or there's 1 over k squared, I guess, in this case. So that's 0.04. If you want to find what k is then 1 over k would be equal to the square root of that, so 0.2. And then if you want to find 1 over k cubed, that would be 0.04 times 0.2, 0.008. So we don't know what the volume of x is, but we can find it using this. So we'd say volume of x is equal to the volume of y, so 1250, times 1 over k cubed, which is going to be 0.008, and that gives us 10. So the volume of x is 10, and then what do they want? The sum of the two volumes? What is the sum of the volumes of x and y? Well, if x is 10 and y is 1250, then you just do 10 plus 1250, which is equal to 1260. So this one did, even though I just said I think most of the scale factor ones have to do with area, this one did relate it to volume as well. But yeah, it seems like scale factor is a big concept in the SAT. The floor of a ballroom has an area of 600 square meters. So the floor is 600 square meters. Did it say it was square? Yeah. No. The floor of a ballroom. So it didn't say what the shape is. It could be a rectangle, it could be even a circle or a triangle or something. It's probably going to be a quadrilateral. An architect creates a scale model of a floor of the ballroom where the length of each side of the model is 1/10 times the length of the corresponding side of the actual floor of the ballroom. What is the area in square meters of the scale model? All right, well, again, we don't know what shape it is, but it doesn't actually matter what shape it is, because when you scale it down, the way that's going to affect the area is basically each side or each dimension would be multiplied by 1/10. So it become like 1/10 x by 1/10 x, like that. So the area is actually going to be multiplied by 1/100th, or you could say it's divided by 100, because again, it's area, so it's scaled, I don't know, like in two different dimensions, so 1/10 squared. So basically we're going to be multiplying 600 times 1 over 10 squared, which is 1 over 100, and that's going to give us 6. A cube has a volume of 474,552 cubic units. What is the surface area in square units of the cube? All right, well, the volume is just going to be the side cubed, right? Because if you draw your cube, it's going to have all three dimensions the same, so side, side, side. I know those look like it could be 5s, but the volume is equal to the side cubed. So if our volume is 474,552, you can find the side by taking the cube root of that volume they gave you. It gives us that the side is equal to if you don't know how to do the cube root, you could just raise it to the 1/3 power. That would be the same thing. But the cube root of that number is 78, according to my calculator. So our side is 78. What is the surface area? Well, for a cube, there are 6 faces that are all the same. All of the faces are a square that's side times side. So if you want to find the surface area of a cube specifically, you can just do 6 times the side squared. And in this case, we just found that the side is 78. So it's going to be 6 times 78 squared. I'm abbreviating surface area there. Let's see, times 78 times 6 gives us 36,504. And if you're doing units, it would be units squared. You don't need to write units in for the SAT though. A right circular cone has a height of 22 centimeters and a base with a diameter of 6 centimeters. The volume of this cone is n times pi centimeters cubed. What is the value of n? All right, well, if it's a right circular cone, it's basically a normal cone. This means the top point there, like that zenith of the cone, is going to be directly above the center of the circle, right? And they meet, you get a 90-degree angle there like that. And it says the height is 22. That's this height inside here. And the diameter is 6. So the important thing is that half of the diameter is the radius. So that means the radius is going to be 3 centimeters. And the reason that that's more important than the diameter is because you use the radius in the formula to find the volume. The volume of a cone is equal to 1/3 times the area of the base, so pi times the radius squared, times the height. It's basically 1/3 of a cylinder that the cone would fit inside of. So we can do that as 1/3 times pi times, we said our radius is 3, so times 3 squared, times our height is 22. And actually for this, 1/3 times 3 squared, you could just say it's 1/3 times 3 times 3. One of those 3's gets canceled out by the 1/3. So you're just left with 3 times 22, which is 66 times pi. All right, so that's our volume. And they said our volume is n times pi. So n times pi is equal to 66 pi. Just divide both sides by pi, they cancel out, and you're left with n is equal to 66. All right, so that would be your answer there. A manufacturer determined that right cylindrical containers with a height that is 4 inches longer than the radius offer the optimal number of containers to be displayed on a shelf. Which of the following expresses the volume V in cubic inches of such containers where R is the radius in inches? It's going to have to do something with adding 4 because this is 4 inches longer, not 4 times longer. Volume is equal to pi, and it said a height that is 4 inches longer than the radius. So height is equal to the radius plus 4. That's 4 more than the radius, right? You have to add 4 to the smaller one to make it equal to this bigger one that's 4 bigger. So in general, what shape is it? A cylinder, the volume is equal to pi r squared times h. It's the area of the base, which is a circle, pi r squared, times the height. So we're going to multiply pi times our radius squared times, instead of the height, we'll substitute in r plus 4, right? Because that's equivalent to the height in this case. It's 4 inches longer. And they don't have this specifically as an option, so it looks like we're going to have to distribute. So we're just going to distribute multiplying pi r squared to both of these terms. That gives us pi r cubed for the first one, r squared times r, plus pi r squared times 4 will give us 4 pi r squared. Now they could change the order of those. The commutative property of addition means it doesn't matter. But pi r cubed plus 4 pi r squared, that's option D. All right, so that's all you got to do there is substitute in this r plus 4 for h and then distribute. Rectangles ABCD and EFGH are similar. The length of each side of EFGH is 6 times the length of the corresponding sides of ABCD. All right, so we've got ABCD, and then you've got EFGH, where they're 6 times longer. They're similar, which means that, right, the angle, well, I guess, are they rectangles? They're rectangles, so all the angles are 90. But right, AB and EF correspond, AD and EH correspond, and so on. And the ratio of AD to AB is the same as the ratio of EH to EF. And you're scaling them all up at the same factor, which is 6. The area of ABCD is 54 units. So this is 54 square units. What is the area of EFGH? So there are actually 2 ways you could do this one that I'm thinking of off the bat. And one of them is just remembering that for area, when you scale it up, you have to multiply it by the scale factor squared. right? So basically you just take 54 and multiply by the scale factor times the scale factor. So 54 times, in this case, 6 squared. And that's going to give us 54 times 36. I'm just going to type that in my calculator, save some time. Gives us 1,944, which we can see is option D. The other thing you could do, like they don't give you what the size of the rectangle is, but you could just choose values that would make it 54. So for instance, you could do 9 and 6. Right? That's something that would work. 6 times 9 does make 54. You don't know that those are the side lengths, but if that works, then it should work for the scaled up one. So you just multiply this side by 6, so it becomes 36. And then you'd multiply this side by 6, it becomes 54. And then 36 times 54 gives you that same value. I mean, that's ultimately what we did down here, actually, of 1,944 units squared. Right, so it just shows that's one way that it could work. You could do the same thing, like it really could be any value. You could even do 2 times 27, right? 2 times 27 would make 54. If you scale them each up by 6, it'd become 12 by 27 times 6. This would become 162. When you multiply 162 times 12, it would still give you 1,944. So I would recommend, remember this rule that when you scale something up, the area is changed by a factor of the scale factor squared. That's really going to come in handy on the SAT. But if you want to check it, if you don't feel comfortable with that, or you think you might have gotten it wrong or have extra time to check at the end, just come up with some values and then see if it works. Or a lot of times I would tell my students, it doesn't matter what the shape is, the way it's scaled up, the area is always going to be scaled up the same degree. Like if it's the same scale factor, any shape's area will be scaled up the same amount. So you could just draw like a 1 by 1 square and then figure out what would happen if you scale it up by whatever the factor is. So k times k, that'd become k squared. It was originally 1 times 1 is 1. Say they said scale it up by a factor of 7. Right, you could go, okay, well, the length and the width gets 7 times longer. 7 times 7 gives you 49. Right, so the area will get 49 times bigger. So it's just a quick way to check it. A rectangular poster has an area of 360 square inches. All right, so we've got 360. I just drew that a little bit too much like a square. We don't know if it's a square, we just know it's a rectangle. So 360 inches squared. A copy of that poster is made in which the length and width of the original poster are each decreased by 20%. So what this means, or each increased by 20%, read carefully. What that means is we originally had 100% of the size of it, right? That being 100% just means that it's the whole thing, right? It's times 1. If you increase it by 20%, that's going to be 100% that you already have plus an additional 20%. So that makes it 120%. If you write that as a decimal, that's 1.2. So our scale factor is actually going to be 1.2. What is the area of the copy in square inches? Well, right, it doesn't matter what the sides were for this. You're just multiplying it by the scale factor squared. So area of the new one is equal to the area of the original times the scale factor squared. So in this case, it would be the area of the original, which, I guess they gave us that. The area of the original was 360 square inches. We're multiplying that by 1.2 squared, which will be 1.44. So 360 times 1.44 gives us 518.4 square inches. That's our new area. All right, the other way you could do it, like I just said for the previous one, you could make up some lengths for it. Like you could treat it like it's a square, or in this case you could do like 60 by 6, or you could do 40 by 9 or 90 by 4. Like that's not going to be an actual length for the poster, but just think if you scale each of those up by, increase it by 20%. So that'd be 6 times 1.2 would become 7.2. And then the 60 would become 72. If you multiply 7.2 times 72, gives you the same thing, 518.4. All right, so that's just a good way to check it. But let's see, do they say what is the area of the thing in square inches? So we would just say 518.4. You don't bubble in the units for the SAT. So that'd be it. A right rectangular prism has a length of 28 centimeters, a width of 15 centimeters, and a height of 16 centimeters. All right, so we've got, it's 28 by 15 by height of 16, like that. Okay. What is the surface area in centimeters squared of the right rectangular prism. So for a rectangular prism, there are six faces, right? Like six either rectangles or squares. In this case, they're all rectangles. And to find the surface area, you're just adding up all six of those. And basically, there are three different edge lengths, and each edge length will match up with each of the other ones 2 different times. So like for 16 and 28, you've got this one in the front, and then you've got one in the back. For 16 and 15, you've got this one over on the right, and then one on the left. And then 28 and 15, you've got the top and the bottom. All right, so you could just basically write it out like this. So surface area is equal to 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. The order doesn't matter. With the commutative property of addition, you can order them anyway. But in this case, we would do 2 times, let's say, 28 times 15, plus 2 times 28 times 16, plus 2 times 16 times 15, or 15 times 16. Just add all of those up. This is 840. This is 896. This one is 480. So this is equal to the surface area. And when you add those three up, 840 plus 896 plus 480 gives us 2,216. It would be centimeters squared. What is the surface area in centimeters squared? So all you have to do is just write the number. Be that. A right circular cone has a volume of 1/3 pi cubic feet and a height of 9 feet. What is the radius in feet of the base of the cone? The volume of a cone is equal to 1/3 times pi times the radius squared times the height. They gave us that the height is 9, so we plug that in, and they gave us that the volume is 1/3 pi. So 1/3 pi is equal to 1/3 times pi times our radius squared times 9. All right, so now we can divide both sides, but we want to solve for the radius ultimately. So let's start by getting the radius squared alone. So 1/3 times 9 is just going to leave us with 3. So if we simplify this side, it's 3 pi times the radius squared. That's equal to 1/3 pi. And now if we want to get the radius squared alone, we could divide both sides by 3 pi. All right, so the pi's will cancel out over here. And then 1/3 divided by 3 gives us 1/9. Over here, the 3's cancel, the pi's cancel. We're left with 1/9 is equal to r squared. So if r squared is equal to 1/9, then r will be equal to the square root of 1/9. Because you do the square root of both sides. You don't have to worry about negative solutions again, because it's a geometry problem. You can have a negative radius. And that's just basically going to be the square root of the top divided by the square root of the bottom. Square root of 1 is still 1. Square root of 9 is 3. So the radius is equal to 1/3. And now to check that, you can just quickly plug it back in to the original equation. So 1/3 times pi times, we said our radius is 1/3. So the radius squared, so 1/3 times pi times the radius squared times our height, which was given as 9. And then that would give us the volume is equal to 1/3 times pi times 1/3 squared is 1/9 times 9. 1/9 times 9 gives you 1, right? That's like 9 divided by itself, 9 divided by 9. And that just leaves you with 1/3 pi, right? And that's what it should be. So 1/3 is our answer. A right circular cone has a volume of 71,148 pi cubic centimeters, and the area of its base is 5,929 pi square centimeters. What is the slant height in centimeters of this cone? The area of the base, so you don't even have to do pi r squared. They already gave you the area of the whole base is 5,929 pi. The volume of a right circular cone, what do you mean by circular cone? I guess just the base is a circle. Usually that's what cone would imply, but it's going to be 1/3 pi r squared h, like we just said. It's like 1/3 of the cylinder that the cone would fit inside of. So the pi r squared is the part that we already have. Right, that's this thing. Like you could write 1/3 times the area of the circle, the area of the base, times the height. So we'll plug this in for the volume. So 71,148 pi. Then we'll leave the 1/3 and we'll put in this area of the base that they gave us. And we want to find the height. So they have the slant height, or we want to find the slant height. So you can use the height to find that. But for right now, the height is what's in here. For a cone, it's like that. the height is here. The slant height would be this length here. So we're gonna have to actually make a right triangle here. Does that mean, will we have to find, I do believe that means we might need the radius as well. So to find the radius, we know that pi r squared is equal to 5929 pi. So you can divide both sides by pi. That leaves us with r squared is equal to 5929. So to find r, you just do the square root of 5929. Square root of both sides leaves you with r. So square root of 5929 is 77. So our radius will be 77. We can use this up here to find the height. And then once we have both of those, we can find this slant height. That's what they're looking for. 1/3 times 5929 is not a whole number. So let's just leave that as a fraction, I guess, for now. But we can divide both sides by 1/3 times, or let's do it like this. We'll divide both sides by 5929 pi over 3. Which is basically like you're multiplying it by 3 over 5929 pi. And that over 3 is coming from the 1/3. Right? So here, this will cancel out everything. The pi's will cancel. And then if we multiply 71,148 times 3 over 5929, same as dividing by 5929 over 3, gives us 36. So h is equal to 36. So that's this height right here. Now, the way that we can find the slant height, what I labeled x there, is using the Pythagorean theorem. We draw a right triangle. The height is here, so that's 36, what we just found. The radius was what we found here by doing the square root of 5929. That's 77. And then you just do the legs, each of the legs squared. So a squared, which is in this case 36 squared, plus b squared, which is 77 squared, will be equal to that slant height. Usually I'd write it as c squared. In this case, I'll write x squared, because that's how I labeled it on the diagram. And now 36 squared is 1296 plus 77 squared is 5929. You add those two together. And I guess, okay, so we actually didn't need to find that it was 77, because if you thought ahead, you'd go, well, if I'm doing the Pythagorean theorem, I'm going to be squaring it. So I could figure out that that's what it is squared. But anyway, when you add those two together, it gives you 7225, which is equal to x squared. Then and x again is our slant height, which is what we're looking for. So to find the slant height, you just take the square root of both sides. So x is equal to the square root of 7,225. It's equal to 85. All right, so 85 is our slant height. Now the other thing you could have done, once you found that the radius was 77, right? So once you figure out that the radius is 77, the slant height, because the radius is a leg of the right triangle, the slant height has to be longer than the radius. It also has to be longer than the height. In this case, the height was way less. Because the second biggest option was 77, which is the length of the radius, then you know it had to be d, right? It had to be the thing that's bigger than that. So say you got to this one and you were running out of time. Maybe there's only a minute left, you couldn't do all of this math. Then you could just figure out one of these dimensions. So find just the height or just the radius, and then go, okay, it's gotta be bigger than that, and there's only one option that's bigger than that. Now, say you found the height first, then there'd be two different options that are bigger than that. If you're really pressed for time, you're not gonna be able to finish, you could just choose between those two. It's at least a 50-50 shot instead of 1 out of 4. But yeah, I mean, this is, it doesn't take too long to do, so hopefully you just do the Pythagorean theorem, you'll be good. Two identical rectangular prisms each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is k centimeters squared. So they're identical, they're just the same exact thing. And their heights are both 90. And it said the surface area is k centimeters squared. If the prisms are glued together along a square base, the resulting prism has a surface area of 92 over 47 k centimeters squared. So the reason for that is if you glue them together along this base, you lose the area of that side for both shapes, right? So a rectangular prism usually will have 6 faces. So each of them has their own 6 faces, and those will all still be showing and still be part of the surface area, except for this one and this one. So basically 5 out of 6 of the originals for each shape we'll be showing. Because otherwise it would just be 2k, because you have the surface area of one plus the surface area of the other one, they're both k. So what is the side length in centimeters of each square base? 90 is the height. The square base, they're talking about like the bottom part, so not the 90 part. Originally, if it's a square base, then the original surface area is equal to, right, 2 of those square bases. So you have one on the top and one on the bottom. 2 times, let's call it x squared. Because what we're finding is x, the side length of the square base, plus you're going to have each of those x's will share 2 sides with the height. So that would be 2 times 90 times x plus 2 times 90 times x, but we could just call it 4 times 90 times x, right? Because there are 4 of them in total. All right, so that means that the surface area is equal to 2 times x squared plus 4 times 90, which is 360 times x. All right, so that's equal to the surface area of just one of those shapes. Now, if you did the total of 2 of them, so double the surface area of one, then that would be just 4x squared plus 360x times 2 is 720x. Right, so that would be just if you had them both not glued together. But when you glue them together, you lose an x by x on one of them and an x by x on the other one. So you're basically losing 2 x squareds. So the surface area of them glued, I'll say that surface area glued, is equal to 2x squared plus 720x. I think of it as like we lost 2 of those x squareds. Right, this one and this one where they're touching. What's interesting is if you put this 2x squared plus 720x over the original thing, which was 2x squared plus 360x, that will be equal to this fraction here, right? 92 over 47. Because you could treat it as like this one's surface area is 92 over 47k. This one is just k. The k's would cancel out and just leave you with that fraction. So then what we could do is cross multiply this here. So you would get 47 times 2, 47 times 720. So 47 times 2x squared plus 47 times 720x. And let me move this over so I have a little more space. And that will be equal to 92 times 2x squared plus 92 times 360x. And now 47 times 2 gives us 94. So this is 94x squared. 47 times 720 is 33,840x. And that's equal to 92 times 2. Going to be 184x squared plus 92 times 360 gives us 33,120x. All right, so now if we subtract, let's put the x squareds on one side and the x's on the other side. So minus 94x squared minus 94x squared. That leaves us with 90x squared on this side. And that would be equal to, let's see, we're going to subtract 33,120x from both sides. And that will leave us with, what is that, 720x. Okay, so we have 720x is equal to 90x squared. Now we're trying to find x, and we can just divide both sides by x here, because we don't have to worry about x being like 0 to make it undefined, because we know x has a length, right? It does exist, this shape. So it leaves us with 720 is equal to 90 times x. And then to get x alone, we'll just divide both sides by 90. That will give us that x is equal to 8. All right, so x is equal to 8. And to check that, we could find the surface area of the original shape, which should be k. So it's 2 times 8 squared plus 4 times 90 times 8. So 2 times 64 plus 4 times 90 times 8 gives us 3,008. Right? And that's the surface area of the original thing, right? This thing right here. And then for the glued together shape, which we're using this formula here, that would be equal to 2 times 8 squared plus 720 times 8. That gives us 5,888. And again, that should be equal to 92 over 47K. And to check that, let's just do 3,008 times 92 over 47. Because that should be equal to 92 over 47K. And that gives us 5888, right? So that checks out. All right, so x is equal to 8, so that'd be b. All right, so that was like, it probably felt like a lot of work there. And, if you don't feel comfortable in your algebra skills, that could be a pain. But note that it is also multiple choice. So if you feel like you wouldn't be able to do this part, as long as you can get these two equations, so if you can figure out what the equation for the surface area of the first shape is and what the surface area of the glued shape is, make sure that you're removing those two x squared parts, then you could just plug them all in, like plug in the x values for x and see what your surface areas end up being and verify whether this part is actually true. The volume of right circular cylinder A is 22 cubic centimeters. What is the volume in cubic centimeters of a right circular cylinder with twice the radius, so double the radius, and half the height? All right, so volume A is just going to be pi times the radius squared times the height. That's the volume of a cylinder. And they gave us that is equal to 22. For this cylinder B, that's going to be pi times double the radius. Instead of r, we're going to do 2r squared. Make sure that it's in parentheses, so you're squaring the 2 as well as the r. And then our height would be half of the original height. So that would be height over 2, where you do 1/2 height. All right, so when you multiply this out, it gives you pi times 4r squared times 1/2 times height. 4 times 1/2 is 2. So it's going to be 2 pi r squared h. And pi r squared h was volume A, so we could substitute that in. 2 times volume A. All right, so we know volume B is equal to double volume A. Right, even though you'd think, oh, you doubled one of the things and halved the other, so those would cancel out. Well, the thing that you doubled, you squared that doubling. So you basically multiplied it by 2 twice, and then you only multiplied by 1/2 once. So you're still left with double. And then we just plug in our volume A, which we have right here. So volume B is equal to double of 22, which is equal to 44. So that's all you got to do there. All right, what is the area in square units of the triangle formed by connecting the 3 points shown? I'm going to do that perfectly, but this one is 5, 3. This one is 4, -3. And this one over here is -3, 4. Okay, so some of my students would try to find the base, and then they would they would choose one of these as a base and do the length using the distance formula, or you could make a right triangle and find the hypotenuse, and then they would try to draw an altitude from it, right? Make a perpendicular line that passes through that point. That's a little bit too tedious. There's something else called Heron's formula, where if you have the lengths of the 3 sides, you can plug it in. You do like the square root of the semi-perimeter times the semi-perimeter minus one side times the semi-perimeter minus another side times the semi-perimeter minus the third side. That could work as well. If you've used Heron's formula before, you feel comfortable with it, that wouldn't take that long, but it would mean doing the distance formula or right triangles to find all of these side lengths. What I prefer for a problem like this is to just draw a rectangle around it, right, so that it encompasses the entire thing. The fact that they drew the coordinates makes it easier. And then you can find the area of these right triangles here. So I'll color in the right triangles I'm talking about in purple pretty easily, because for a right triangle, the base and the height are just the sides, right? If they're at 90 degrees to each other. For this triangle that we have here, I don't think these sides are even at 90 degrees, any of them. This one could be, but you'd have to test it using the, you'd find the slope of one, find the slope of the other, see if they're perpendicular or they're opposite reciprocals. But so this triangle, and this triangle. So we can find the area of that rectangle just by doing the length times the width, and then subtract these triangles that are outside of the shape that we want, right? Because we ultimately want this area that's red here. So if it's -3 to 5, that's a length of 8. You could also count the squares, 1, 2, 3, 4, 5, 6, 7, 8. And then this one goes from -3 up to 4, so that's a length of 7, or a width of 7. 1, 2, 3, 4, 5, 6, 7. You could count them to verify as well. So the area of the triangle, again, is equal to the area of the rectangle minus the area of those 3 triangles, 3 like right triangles like that. Okay, so the area of our red triangle is equal to, we said it's 7 times 8, which will be 56, minus, here we've got 1/2. Oh, and yeah, the little triangles, you have to also find the lengths of those. So this one is still 7 over here, but it's 7 down here as well. So it's a 7 by 7. So this would be 1/2 times 7 times 7, right? The base and the height, minus the next one would be, let's see, 1 by 6, right? This only goes up 6. So 1/2 times 1 times 6 minus, and then this one is 8 by 1. So that's 1/2 times 8 times 1. So ultimately we're subtracting, well, 7 times 7 is 49, so 1/2 of 49. And then you're subtracting, well, 1/2 times 6 is 3, so this little one here is just an area of 3. 1/2 times 8 is 4. 4. All right, so half of 49, that's going to be 24.5. So minus 24.5 minus 3, or 3 and 4 make 7, so you're subtracting 7. And then all of those together, you're subtracting 31.5. So it's 56 minus 31.5, which gives us 24.5. And just eyeballing it, it does look like it's about half, right? Half of 56 would be 28. It looks like it's a little less than half of that rectangle. And you could also write this, I guess, as a fraction. That's true for any of the decimal answers. Or if I gave it as a fraction, you could write it as a decimal. They would accept either of these. What's interesting, with some math competitions, they won't give you a decimal fraction answer if they don't specify that in the question. But for the SAT, they could. So just, if you feel like, oh, I don't think it should be a fraction or a decimal answer, go back and check to make sure you didn't make a mistake. But in this case, this is correct. And you could kind of verify it based on just the fact that they have this 7 by 7 one here, right? This has to have an area that's a half unit, and then these ones are whole units. So if the whole thing is 56, whole number, then there's a half unit in here and a half unit in here that are not matched up. All right, circle A has a radius of 3n, and circle B has a radius of 129n, where n is a positive constant. The area of circle B is how many times the area of circle A? All right, well, first you can just find the scale factor. So K would be equal to the side length of B. So that's going to be 129n divided by the side length of A. So that's 3n. And side length, it's actually a radius, right? Not a side length, but that's just a one-dimensional unit or one-dimensional measure of it. So the n's will cancel out, and then 129 divided by 3 gives us 43. So your scale factor, your K value, is 43. If you feel more comfortable, you could also rate it as 43 over 1. Right, that's like the ratio of the sides of B to the sides of A. Now for area, the area of B is going to be equal to the area of A times K squared. Right, because basically if the radius is 43 times longer, then when you multiply it by radius squared, because the area of a circle is equal to pi times radius squared, then you're squaring that K value twice. So it's like pi times KR squared is equal to pi times radius squared times K squared. Okay, or just you could remember that for area, you have to multiply it by the scale factor squared. So in this case, that's going to be equal to the area of the first one, area of A times 43 squared. And 43 squared is equal to 1849. So 1849 times the area of A. And so that's how many times bigger it is. How many times bigger? Okay. You could also just, I assume you'll have a calculator when you're doing it, but note that when you scale up the sides by something like 43, the area is going to be scaled up at a much faster rate. Right? Same thing with volume. The volume would be 43 cubed times bigger. So that's, I know this is not a 3D shape, so you can't have a volume, But if the scale factor is 43, then the volume goes up by a factor of almost 80,000, 79,507. So just keep that in mind, like when you scale up shapes, whether it's a 2D or 3D shape, it affects the area and the volume at a much faster rate. The line segment shown in the xy plane represents one of the legs of a right triangle. The area of this triangle is 36 root 13 square units. What is the length in units of the other leg of this triangle? All right, so first we have to find the length of this. And you could do that actually by making a different right triangle. So something like this. Ooh. A lot of teachers will tell you just use the distance formula, which the distance formula looks like this, where it's basically change in y squared plus change in x squared. And then you do the square root of that whole thing. That's just coming from the Pythagorean theorem, right? Because change in y squared is here, change in x squared is here, right? So you're doing a squared, that's here, plus b squared is here, is equal to c squared, and then to get c, you do the square root of it. So that's where the distance formula comes from. But we just go, okay, this is 1, 2, 3, 4, 5, 6. This is going 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 6 squared plus 9 squared is equal to our distance squared. And that means that the distance is equal to, well, 6 squared is 36, 9 squared is 81. So distance squared equals 36 plus 81, which is 117. So then to find the distance, you just do the square root of both sides. Distance equals square root of 117. All right, so that's that length there. And now we're making a right triangle from this. So it doesn't tell you if it's going up or the other way, it doesn't really matter. But for a right triangle, why that's important, is that for a right triangle, the sides, like the two legs, are going to be perpendicular to each other. That's the definition of a right triangle, which means that if one of them is the base, you could treat the other one as the height to find the area. The area of a triangle is equal to 1/2 times base times height, or base times height over 2 is the same thing. So if we know our base is the square root of 117, like that, we can use that to find the height. So right, we know our area is 36 times the square root of 13. So 36 root 13 is equal to 1/2 times the square root of 117 times the height. Now, I'll show you first how to do it with the calculator, which would just be basically you would, well, first we get rid of that times 1/2 by multiplying both sides by 2, which gives us 72 root 13 is equal to square root of 117 times h. And now we could just type into our calculator this, right? You could do 72 root 13 divided by square root of 117, because these cancel out. And just make sure you have it in parentheses, the whole denominator. 72 times the square root of 13 divided by parentheses square root of 117. So the height is equal to 24. All right, so without even doing any math in terms of like figuring out what square root of 117 is simplified, you could figure that out. All right, so that's probably what a lot of my students would do. And you know, it didn't take any time, so I will not discourage that. But you could also figure out what is in the square root of 117. And the fact that we know the final area is square root of 13, we know, you know, I mean, that could be coming from one of these, but if it was, then this one wouldn't have a radical. So it probably, 117 probably has 13 in it. So you do 117 divided by 13, which is 9. So that means you could change, instead of 107, square root of 117, you could treat that as the square root of 9 times the square root of 13. And square root of 9 is 3, so that's 3 root 13. All right, so 3 root 13 is the same as square root of 117, so we can just substitute that in here, and we'd say 36 root 13 is equal to 1/2 times 3 root 13 times h. Now, when we do it, you could divide both sides by the square root of 13, and that will just cancel out those radicals. We're left with 36 equals 1/2 times 3 is 3/2 times h. And then to get h alone, you just multiply both sides by 2/3, right, the reciprocal of 3/2. And that gives you h is equal to 36 times 2/3 is equal to 24. All right, so you don't need a calculator to do this one. But since you have one, you know, just doing it this way, I guess it probably saves at least 10 or 15 seconds. And if you're not as comfortable with radicals, then that might be the move. But I would recommend practicing with radicals, so that's not something that could trip you up. The dimensions of a right rectangular prism are 4 inches by 5 inches by 6 inches. What is the surface area in square inches of the prism? All right, so it's 4 by 5 by 6, like that. The surface area is, you've got 2 of these 4 by 6 sides, 2 5 by 6s, and 2 5 by 4s. Right, so each of those edge lengths will match up with each of the other ones 2 times. So we just do 2 times 4 times 6 plus 2 times 4 times 5 plus 2 times 5 times 6. It doesn't matter what order you write them, just make sure that all of them are accounted for. So that's 8 times 6, which is 48, plus we've got 8 times 5, which is going to be 40, plus 2 times 30 is going to be 60. So 40 plus 60 makes 100, 100 plus 48 makes 148. Right, so that's your answer. That one was a lot easier than some of the previous ones. A right triangle has sides of length 2 root 2, 6 root 2, and square root of 80. What is the area of the triangle in square units? So it's a right triangle. We know the longest side is going to be the hypotenuse. If you want, what you could do is you could type all of these radicals in. Now we know 6 root 2 is bigger than 2 root 2. So you could just type in 6 root 2 in your calculator. Which gives you 8.485. We know that's 3 times bigger than the 2 root 2 one. And then square root of 80, which is 8.944. So they were nice about it. But I was thinking they might be trying to trick you with, they could have put the hypotenuse second, but you do want to make sure you verify this is the biggest one before you write it out. So square root of 80 is down here. The longer leg is 6 root 2, and the shorter leg is 2 root 2. Okay, so it looks like this. What is the area of the triangle in square units? Well, as we said in a very recent problem, for a right triangle, you can use the 2 legs as the base and the height. It doesn't matter which one's which, right? But area is equal to 1/2 times base times height. They're, right, an altitude, a height, just means it has to be at 90 degrees from the base and go up to that point. That's like furthest from there. So that would be 1/2 times, let's call it 6 root 2 times 2 root 2. In this case, root 2 times root 2, that's like the square root of 2 squared, which cancels out the square root. Or you can think of the square root of 2 as what number times itself equals 2. So we're timing it by itself. So that will give us 1/2 times 6 times 2 times 2. Right? The extra 2 is from the root 2 times root 2. And then I'm just going to do one of these 1/2s cancels out with one of the 2's, and that leaves you with 12. 6 times 2. Right, so that will be your area. Triangles ABC and DEF are similar. Each side length of triangle ABC is 4 times the corresponding side length of DEF. So ABC is the bigger one. Maybe we could draw that just to make sure we remember it. It doesn't say if it's a right triangle or whatever. Kind of like that. It should be even bigger than this, but the area of triangle ABC is 270 square inches. What is the area in square inches of DEF? All right, well, we've got to divide each of the sides by 4. So that means the area will be divided by 4 squared. So it's divided by 16. So we could just do 270 times 1 over 4 squared, which equals 270 times 1 over 16. 270 divided by 16 is 16.875. So 16.875, did it say what the units were? Square inches, so this would be inches squared. Again, for the SAT, you just type in that answer. If you want to leave it as a fraction, you could just write 270 over 16 and then simplify that. So there's a 2 in each of those. So divided by 2 would give you 135 over 8. And that's fully simplified. So either of those answers would be acceptable. I think for the SAT, they would have you round to the nearest hundredth, even though they don't say it in the question. Which what's interesting for the SAT, like normally you'd be taught if it's 5, you round up. So you'd write 16.88. But they actually also will let you, if it's exactly a 5, you can round down. So they would accept either of these answers. I'd write it like that. But if you don't feel comfortable rounding, just convert it to a fraction. Some calculators will do that anyway. If you put the mode into fraction mode, or just write 270 divided by 16, just simplify that. A cube has a surface area of 54 square meters. What is the volume in cubic centimeters of the cube? Well, we know for a cube, it's 6 equal squares, like equal size squares for the surface area. So you can treat that as 6 times the side length squared is equal to the surface area. Now if you divide both sides by 6, that gives us that the side squared is equal to 9, which means that our side length is 3. So if our side is 3, and you want to find the volume of a square is just the side cubed, right? Because this side length is the length, the width, and the height. So that's equal to 3 cubed, which is equal to 27. And, oh, that's the last one. It's interesting. That one, I really feel like they could have put this under medium or something, but I guess just some of the other ones are more time consuming. Some people might struggle with this if you haven't done math with surface areas of cubes before. You might not very quickly go to the 6s squared. But all right, well, that's how you do all of the area and volume questions that are listed as the highest difficulty level on the SAT question bank. I would say they did have a lot of scale factor in here, so make sure you're really comfortable doing scale factors for areas, and even there was that one volume one. Seems like cones come up a lot, cylinders come up a lot, rectangular prisms come up a lot. So those are the main shapes that you had to do. I don't think they had any spheres on here. That might be, they did have, I think they had one sphere that was inside of a circle or inside of a rectangular prism. Yeah, right, this one. So I guess the sphere came up once. You know, I would make sure you know those formulas. I'm sure they give you access to like formula sheet, but if you know them and are comfortable with them, you're less likely to make a mistake than if you were dealing with it for the first time. But really, scale factor was the most common topic I would say on here, and that's one that a lot of times students haven't really gotten that much practice with. I know my geometry class, we did a lot of scale factors, and I'd put it on every test, but I don't think it's really that big of a concept generally, especially for a 2D shape that if you scale it up, the area is multiplied by the scale factor squared. You know, that's a concept that might be touched on, but is not very regularly talked about. And then I think they only had that one where you find the area of a triangle, but that is really the best strategy, in my opinion, is drawing a rectangle around it and then taking out these triangles here. But as I mentioned, there are multiple ways that you could do that. Whichever one you're more comfortable with will work out, but just make sure that you're being time efficient. And right triangles, yeah, knowing that for a right triangle, you can easily find the area just by doing 1/2 times base times height. And yeah, that's the main gist of it here. If you have any questions or suggestions or any concerns, leave those in the comments below, and thank you for watching.